Hi class, this video continues in Chapter 2, Introduction to Reasoning and Proofs, by moving into Section 2.3, and this is about conditional statements. So we have two objectives. The first one is we want to recognize conditional statements and their parts, and the second thing we want to do is write converses, inverses, and contrapositives of what we call conditional statements. All right, so let's start with what a conditional statement is. So a conditional statement is a statement that is written or can be written in that if-and form. Okay, we talked about the if-and a little bit in section 2.2. All right, but when a statement is in if-and form, the phrase that follows the if part is the hypothesis, and the phrase that follows the then is called the conclusion. So if-then is a hypothesis and a conclusion. So for example, if a figure is a pentagon, then it has 5 sides. This is our hypothesis, right, that a figure is a pentagon, and then the conclusion here is that it has 5 sides. So a hypothesis and a conclusion. Let's do another example. If it is snowing, right, that's my hypothesis, then the conclusion is it is cloudy. Right, so if it comes after the if, it's the hypothesis. If it comes after the then, it is the conclusion. All right, when working with conditional statements, it's often handy to use shortcut notations. All right, you may see any of the following. Hypothesis, conclusion. So if P, then Q. Or P implies Q. That's another way. And then this right here, the arrow, P implies or P then Q. That's what that arrow means. It just says P implies Q, which is the same thing as if P, then Q. All the same. All right, identify the hypothesis and the conclusion. All right, so if an animal is a turtle, then the animal is a reptile. Well, the hypothesis is an animal is a turtle. That's what comes after the if. And the conclusion is what comes after the then. Well, the conclusion is the animal is a reptile. Let's do another one. If a number is even, then the number is not odd. Well, the hypothesis comes after the if, the number is even, and the conclusion then comes after the then, the number is not odd. All right, let's talk about writing a conditional statement. All right, a hypothesis P and a conclusion Q are given. Use them to write a conditional statement P implies Q. So a figure is a square is the hypothesis, and the conclusion is the figure is not a rectangle. So if a figure is not a square, excuse me, if a figure is a square, then you do the conclusion, the figure is not a triangle. Another one, the hypothesis 9 is a perfect square. The conclusion, 9 is not a prime number. All right, so let's write it as a conditional statement. So if the hypothesis, 9 is a perfect square, then the conclusion, 9 is not a prime number. All right, write the following statement in if-then form. All right, so acute angles measure less than 90 degrees. How would we do this? Well, if an angle is acute, that's our hypothesis, then the conclusion, it measures less than 90 degrees. I basically went like this, cut it in half. If the first part, then the second part. All right, a conditional statement may be either true or false. All right, a conditional statement is true if every time the hypothesis is true, then the conclusion is also true. A conditional statement is false if there is a counterexample in which the hypothesis is true, but the conclusion is false. And remember, we talked about counterexamples in section 2.2. All right, so is a conditional statement true or false? All right, so determine whether each of the following conditional statements is true or false. If an angle measures 92 degrees, then it is an obtuse angle. All right, well, this conditional statement is true. All angles that measure 92 degrees are obtuse angles. So that's a true statement. All right, if a month begins with the letter J, that's my hypothesis, then my conclusion is the month has 31 days. Well, January has 31 days. That's great. But this conditional statement is false. If you look at the month of June, all right, that starts with a J, all right, but only has 30 days. So you're able to prove with a counterexample. All right, negation. The negation of a statement is formed by writing the negative of the statement. All right, so note the notation for a negation is equals comma. So not P, all right, is read not P. Right, so this right here, this squiggly line P, this is the negation. Right, so let's write a statement. The computer cover is red. Well, the negation of this is the computer cover is not red. The rarest blood group for humans is AB. The negation is the rarest blood group for humans is not group AB. All right, this right here, I encourage you to copy and have in your notes handy. All right, we have a conditional statement. The converse is to switch the hypothesis and the conclusion. So you start with PQ, then you just whoop, you flip them and it goes Q implies P. The inverse is you negate the hypothesis and the conclusion of the conditional statement, so you make it not P implies not Q. You started with P and Q. And the contrapositive is you negate the hypothesis and the conclusion of the converse statement. So you flip P and Q, and then you negate them. All right. Let's do some examples. All right. If two statements are both always true or both always false, we call them equivalent statements. So the conditional statement and the contrapositive statement in the table are both true and are examples of equivalent statements. Right? The converse statements and the inverse statements are both false and are examples of equivalent statements. So the conditional and the contrapositive are conditional statements because they're both true, right? And the converse and inverse are equivalent statements because they're both false. So as long as they're both false together or true together, you're good. All right, and you can read through these statements to see if what I mean by true and false here. All right, let's take a conditional statement. All right, so let's write the converse, inverse, and contrapositive of the conditional statement of this given one. So this is my original statement. If it is raining, then it is cloudy. All right, the converse, remember the converse takes Q and P and flips them. So the converse is if it is cloudy, then it is raining. All right, I just flipped the it is cloudy and it is raining. All right, my P and Q got flipped here. Let's do the inverse. All right, the inverse negates these. So it says if the original statement was if it is raining, then it is cloudy, it becomes if it is the inverse is if it is not raining, then it is not cloudy. All right, I took my P and Q's and I negated them. All right, finally, the contrapositive. I take my Q and I negate it. So if it is not cloudy, then I take my P and I negate it. Then it is not raining. And all I did, forgive the typo here, but these are supposed to be the squiggly lines. Not Q implies not P. That is the contrapositive.